In this video, we have another radical equation. We want to solve for the real solutions. Now, it's important to notice that an x squared minus 3x here, got an x squared minus 3x here. We'll see what we can do with that a little bit later on. But first, let's go ahead and simplify this. Normally, when we have a radical equation, possibly we want to isolate the radical dealing with the square root here, so we go ahead and isolate the radical, square both sides. So I'm going to bring this 2 over to this side. This will be a minus 2 over here. Change the sign. And then the radical goes over to the right side. It becomes a plus, so this will be the square root of x squared minus 3x. Now we have the radical isolated, so we're going to square both sides. So on the left side, I got x squared minus 3x minus 2 squared. So this gets multiplied by itself. But I'm going to look at that as a binomial. So I'm going to look at that as this expression minus this expression. So I can use this little formula here from algebra. You have a minus b quantity squared. Treat that as a binomial. You square the first term. That gives me a squared. It's a minus there, so I put a minus here. If it was a plus, I'd put a plus. So it's double the product of those two terms, a and b. So this would be a squared minus 2ab plus second term b squared. So this becomes a squared minus 2ab plus b squared. So in the same way then, treating this x squared minus 3x as your a, this would become x minus 3x quantity squared minus double the product of these two terms, so it'll be 2 and the x squared minus 3x, so it'll be a 4 here. 4 x squared minus 3x. And then it's plus 4. So treat the first expression here, x squared minus 3x, like your a over here in this formula. We have a minus, and then the b would be the 2. You square this term here, we get x squared, x minus 3x quantity squared. Double the product, that's 2 times x squared minus 3x, it becomes a 4 here. Minus 4, x squared minus 3x, and then the plus here, and then the 2 squared is 4. And then on the other side, squaring that just eliminates the radical. So I simply get x squared minus 3x. And notice, I got x squared minus 3x there, x squared minus 3x there. So you can treat that as one term. Bring it over to this side. That becomes a minus x squared minus 3x. But here I have a minus 4 over here. So putting this like this and bringing it over, this becomes a minus 1. And then over here, that becomes a minus 5. So just to save us some time here, let me just change this to a minus 5. On the left side, on the right side, what I have is 0 then. Now I could use a substitution here, like we did in another video, and just make this a y here. It's x squared minus 3x, and this is x squared minus 3x. I could call that a y, and a y, and then factor, say, y squared minus 5y plus 4. But I'm just going to leave it the way it is and just factor it. But you could use a substitution. So now we just say, okay, this x squared minus 3x squared factors into, and this would be x minus 3x. And this is an x squared here. So it'll be x minus 3x, x minus 3x. So again, the factors of x squared minus 3x squared would be x minus. So then the factors of x squared minus 3x would be x squared minus 3x squared would be x squared minus 3x. And x squared minus 3x. And for the 4 here, I can factor that into 4 and 1. So this would be a minus 1 here. And a minus 4 here. On the right side, I still have 0. So again, it works this way. X squared minus 3x times x squared minus 3x, of course, gives me the x squared minus 3x quantity squared. And then minus 1 times this right here gives me minus 1 of these, x squared minus 3x, and a minus 4, x squared minus 3x. Add them up, that's minus 5, x squared minus 3x. So those are the factors. So then I simply set each factor equal to 0 here. I get x squared minus 3x minus 1 can equal to 0, or x squared minus 3x minus 4 can equal to 0. So I actually get two quadratic equations. Now this one here is going to factor here. I can factor this into x minus 4 and x plus 1. That product can be 0. So that means that x minus 4 times x plus 1 equals 0. That would tell me that x could be 4. In other words, this factor could be 0. That's going to be at 4. Or this factor could be 0. So I get, for this one then, x minus 4 is equal to 0 at 4. So x should be 4. But this factor could be 0. X plus 1 would be 0 at negative 1. So those are two possible real solutions. X equal to 4, x equal to negative 1. Now, anytime you deal with a radical equation where you're going to square both sides, or in some cases take it to the 4th power. In other words, if you're going to take one side to an even power, that always involves a situation where you could have extraneous roots. In other words, you could get answers that will work for the squared equation, or the one you take to the 4th power, but not for the original. You always have to go back to the original. And that happens because I can have a false statement, say negative 1, I say negative 1 equal to 1. That's not a true statement. But if I square both sides, negative 1 squared is 1. 1 squared is 1. So I get a true statement. So anytime you square both sides of an equation, there's a possibility of introducing extraneous, what we call extraneous solutions. I mean solutions that will work for the squared equation, but not for the original. So I put here x equal 4 and negative 1 to be solutions, but they're not solutions until you check them. So let's try, go back to the original equation here. Put a 4 there, as 4 squared is 16. Then put a 4 here for the x, that's 4 times minus 3 is a minus 12. This is 4 right here. And now go to the radical. Plug in a 4 there. And of course we're going to get the same number because it's x squared minus 3x. So we're going to get 4, but then you have to take the square root of that. That's 2. 4 minus 2 does give you 2. That one checks. Now let's check the negative 1. Put a negative 1 here where the x is. Negative 1 squared is 1. Negative 1 times a negative 3 is 3. So this comes out to 4. I'll go to the inside. The square root here, the radicand, put a negative 1 there. Negative 1 there. Gives me 4, but the square root of 4 is 2. 4 minus 2 does give you 2. So that checks. So I know for sure these are real solutions. Now let's go back to the other equation here. X squared minus 3x, x squared minus 3x minus 1 equals 0. That's again a quadratic. This one doesn't factor. So you'd have to use the quadratic formula. Now if you use the quadratic formula, or you can use the method of completing the square, it doesn't factor. This is what you're going to get. I won't work this out. You can do the quadratic formula or method of completing the square. But for this one, you're going to get two possible solutions. 3 plus or minus the square root of 13 over 2. So this is a 3 plus or minus the square root of 13 over 2. So one solution is 3 plus the square root of 13 over 2. Another one is 3 minus the square root of 13 over 2. And notice how messy this is going to be. How tedious, I should say, maybe. To check to see if these two are solutions, you'd have to plug it in here. Can you see a short way to do it? To confirm whether these two are solutions. Let me rewrite it. Rewrite this equation: x squared minus 3x. Add 1 to both sides, so I see that x squared minus 3x is equal to 1. So instead of plugging these in to confirm whether they're solutions or not, let's look at x squared minus 3x equal to 1. X squared minus 3x is equal to 1. So that's 1. Then it's minus, and this is x squared minus 3x. That's 1. So it's 1 minus 1, or 1 minus the square root of 1, which is 1. So this actually comes out to 1 minus 1. That doesn't equal to 2. That equals to 0. So instead of plugging these in and doing all the algebra and showing that that result is not going to come out to 2, you can just do this. X squared minus 3x equal to 1. Plug it in, 1 there and 1 there. Doesn't get 2. So any solution that I get from this equation then is not going to work. So the only real solutions we have are 4 and -1. Thanks for watching. We'll see you next time.